equations of lines. Essentially, we're going to go through a couple different ways to get an equation of a line. So far, we've been working predominantly with slope-intercept form. So we start with that, but there are other ways to write a line. As you know, there are equivalent equations. There's other ways to rewrite an equation and have it look the same on a graph. So there are different forms of lines and different methods of getting those equations of lines. So here we go. Quick notes, we're going to start with point slope formula, point slope form. Yeah, point slope.
Yeah, when I was sick, I didn't know what lesson to go.
Point slope form. The form for this equation of a line, and this will make sense as we use it. Right now we're just kind of collecting tools for our toolbox. Y minus y1 equals m times x minus x1, where x1, y1 is any point on the line, because then those coordinates will satisfy the equation. And what do you think m stands for? M is the slope. All right, there's one form that can be very useful to us. The second form that we're going to talk about is standard form. The equation for standard form, capital A x plus capital B y plus c equals 0. So the key to standard form is that all the numerical and variable information is on the left, and you have a 0 on the right. And the key here, where A, B, and C are integers. Okay, that means they are whole numbers, positive or negative whole numbers, which means if you end up with a decimal or a fraction, all you have to do is multiply the whole thing by the denominator, and then that will get rid of that fraction, and you'll have A, B, and C as integers. So where they are integers, and another restriction here, A and B are not both 0. Okay, one of them can be 0, but not both of them. Why not both of them? Well, if A is 0, that gets rid of any x's, and your equation only has y's, and you'd end up with a line in the form of y equals something. Well, that's a horizontal line. If B were 0, this whole y term would disappear, and you'd be able to reduce this equation to x equals something, which would be a vertical line. But if they're both 0, all you end up with is a number equals 0 or 0 equals 0, and it's not a line at all, okay? So these are linear equations. Good. And x and y no, I'm not even going to write that. X and y represent real numbers. That's fairly obvious. That's in any equation that we work with at this point. Okay. Then we also have something we've worked on already. We have slope-intercept form. Slope-intercept form, you know, is y equals mx plus b, where m is the slope and b is what?
The y-intercept.
B is the y-intercept. And then just briefly for the sake of review, parallel lines have what?
The same slope.
Parallel lines have the same slope, but different what? Different y-int, thank you. And perpendicular lines. Perpendicular lines have what?
Opposite reciprocals.
Have slopes that are opposite reciprocals. Parallel lines have slope that are the same slope, different y-intercept. Perpendicular lines have slopes that are opposite reciprocal. Doesn't matter where their y-intercept is because lines go forever and ever and ever and ever, and eventually these two lines are going to hit, and it's going to be at a right angle when they do hit. All right, example 1, we're going to write the equation of a line given a point and the slope. So in this line, we have the slope. I'm just going to jot down what I know. The slope is equal to -1/2. And I know it goes through the point A, which is at 3, -4. Okay, so identify what you have. Because I have a point and a slope, I know that I'm going to be using point slope formula. So that's y minus y1 equals mx minus x1. Take a second to look back at the definition that we wrote earlier and see if you know where you need to sub all these things in. Got an idea? So this y stays out front. It's just going to be y because at the end we're going to end up with something in the form of y equals mx plus b. You'll see how that works out. But we know y1 because x1, y1 are the coordinates of point A. Now be careful with your positives and negatives. So right now we have y minus y1. So it's y minus -4. And that's equal to m times this group. Well, m is -1/2. And this group is x minus, and x1 is 3. Okay, all we did was sub in our known values. We know an xy that satisfies the equation, and we know the slope m. And from here, all we do is solve it out using our basic algebra skills. This is on the left, we have y plus 4. On the right, we're going to be distributing the -1/2 to both terms in the binomial. So we have -1/2 x, and then we have +3/2. Okay, we're not quite done yet. We want y by itself. If I'm going for y equals mx plus b, I would get y by itself on the left by subtracting 4 from both sides. Because I'm working with fractions, I'd express 4 as a fraction over 2. Because I have some just ones over here. I have 1.5 to be subtracted from. But this problem actually wants us to write it in standard form. So double check above what standard form is to see which way we should move all of this stuff and what else we should do. Am I allowed to have fractions in standard form?
No.
What can I do to get rid of these fractions?
Multiply it by 2.
Multiply what by 2?
X.
Just
The
x?
whole
The
right side.
entire
The whole right side.
Uh-oh.
It's the whole right side.
Just
If
one
you do
side?
it to one side, you gotta do it to the other side.
If I do it to one side, that would be uneven, right? So I have to do it to both sides. So I'm going to make a little note of that. Multiply everything. There's a good way to think of it. Multiply everything by 2 to eliminate fractions. So I have 2y plus 8 on the left. I have -x plus 3 on the right. Now standard form. What does it ask me to do? I have to get everything on the left side kind of in order. So I want 0 on this side. So I'm going to add x to both sides. Add x, and I'm going to subtract 3 from both sides. All right, so x's and y's, can I add them together and say I have 3 x's now? Or 3 y's? Or 3 xy? No, of course not. They're two totally different things. So I have x plus 2y. 8 minus 3 is 5. And on the right-hand side, we have 0. Now this is in standard form. The coefficient in front of the x is 1. The coefficient in front of the y is 2. The constant is 5. And we have a 0 on the right. In the second example, we need to write an equation given 2 points. Okay, this is going to be another application of point-slope formula, point-slope form. But this time we don't have the slope, but we do have 2 points. So I'm going to just jot down what my 2 points are. I have the point A at -3, -2, and I have the point B at 1, 6. So again, I need point and slope. Well, I have 2 points, so that one's taken care of. How do I get the slope? Can I get the slope? Yeah.
It's like y1, y2 minus y1 over x.
Good. If I have 2 points, I can certainly get the slope. It's the change in y and over the change in x. Now that works because the slope of a line, the slope of this line between A and B is the same as the slope of this line anywhere on the line. Slope is always the same, whether you're taking a big stretch of the line or a tiny little stretch of the line or a piece of the line over here, okay? The slope will be exactly the same forever and ever and ever and ever. It's just a rate at which it changes y with respect to x. So here we go. Plug in what we know. It doesn't matter which point I call point 1 and which point I call point 2, but we'll take our y values first. The difference in the vertical, so the difference in y's is 6 minus -2. That's 6 plus 2, that's 8. And in the x's, in the denominator, we have 1 minus -3. That's 1 plus 3, that's 4. Gives us a slope of 2. Okay? So step 1, determine slope of line. Step 2, apply slope point form. All right, what does that look like? Yep.
Did you add the 2?
All right, so now we are applying point slope form. I'm going to write that again for myself. Y minus y1 equals m times x minus x1. Should be getting close to having that memorized for yourself. If not, keep working on it. And I sub in what I know. Now, I have 2 points to choose from. Which point should I use? Doesn't really matter. Yeah, you could say, oh, use the one with positive numbers, but really you're subtracting in both cases. Then you could say, well, use the one with negative because that's, you know, subtracting a negative is adding up. Anyway, doesn't matter which one you pick. I'm going to take B. The y coordinate is 6. M is 2. We just found that out. Then I have in the brackets x minus 1 because the x coordinate of the point that I chose is 1. Please don't take the y coordinate from point B and the x coordinate from point A. They do not satisfy the equation together, okay? This satisfies the equation, x, y, and this satisfies the equation, x, y. And no other combinations that we know so far can do that.
In the video, you wrote it y minus.
Okay, let's distribute the 2 on the right-hand side. So on the left, we still have y minus 6. On the right-hand side, we have 2x minus 2. And we need this in standard form again. I only have whole numbers. That's convenient. So the last thing I need to do is simply make sure all the important information is on the left, and I have a 0 on the right. So I'm not always going to write this step, but what does that mean? I'm going to subtract 2x from both sides, and I'm going to add 2 1s to both sides. So on the left, I end up with negative 2x plus y minus 4, and on the right, I have 0. And that is in standard form. That's the line that goes through A and B. First find the slope, then apply point slope form. The next example is just going to familiarize us with what a horizontal line looks like and what a vertical line looks like. So for A, you have a horizontal line, horizontal through C, which is 2, 3. Now the key to know for a horizontal line, what's the rise over run? Does it rise at all? It doesn't rise at all. So no matter what you did for slope, you'd have 0 over whatever. If you go over 1, it's 0 over 1. If you go over 7, it's 0 over 7. It always is going to reduce to 0. Okay, so a horizontal line has a slope of 0. There's a couple different ways to think about it. We'll think of it this way first. Horizontal line has a slope of 0. It doesn't rise no matter how far you run. So if we were going to put this in, let's say y equals mx plus b, okay, and then we were going to solve for b, which is our y-intercept, what you would end up with is the idea that the y-coordinate of every point on the line is the same. If it never goes up or down, then whatever the y-coordinate is, that's what it is here, 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 okay? So let's take that note. The y-coordinate of every point on the line is the same. The y-coordinate of every point on the line is the same. So again, I'm going to think of this in terms of y equals mx plus b. This whole term right here, slope is 0. 0 times anything is 0. So this whole term disappears. We end up with y equals the y-intercept, and we know that the y-coordinate is never ever going to change. So if it goes through 2, 3, and the y-coordinate is 3, then what's the y-intercept going to be? 3. It's not going to go up or down or anywhere else. It's just going to go across, and it's going to hit at 3. Okay? So the equation for this line is y equals 3. That's enough information to draw this line where y is always 3. X can be whatever. It can change, but y is 3, and that is across the whole domain. Okay? Good. So that is a horizontal line. We'll always have the form y equals something.
So you just gotta not write the x.
If you know a point that it goes through, you just take that y-coordinate. If it's horizontal, it's going to be y equals that all the way along. Okay? B, vertical line. Vertical line through D, which is negative 4, 1. Okay, same logic applies. This time, the line is going to be expressed as x equals something because the y-coordinate can change, but the x-coordinate will always be the same. So we've got a couple notes. Same here, we wrote horizontal line has a slope of 0. Well, guess what? A vertical line is perpendicular to a horizontal line. Does that make sense? Horizontal, vertical, they're perpendicular. So what should we know about the slope? It's going to be the opposite reciprocal. Well, what happens if you flip this fraction? It's going to be something over 0. What's true? Can you have a fraction over 0? No, it's undefined. Okay? Vertical line has slope that is undefined. The x-coordinate, so has a slope that is undefined, and the x-coordinate of every point is the same. It's always expressed in terms of x. X equals whatever. And if the x never changes, then it's simply the x-coordinate of the point that you were given. So in this case, x equals -4. That represents, let's say on our grid, here's the y-axis, here's the x-axis, and here's -4. Okay, so we have a vertical line at -4, and for this point, this point, this point, this point, this point, this point, the y-coordinate is changing, but the x-coordinate is always -4. So x equals -4 always, no matter what. That's enough to represent that vertical line, okay? If we had to do it in standard form, if we had to express this in standard form, in number A, we would end up with y minus 3 equals 0. Okay, you can see there's no x involved. And here you'd end up with x plus 4 equals 0. No y term involved. Using slope y-intercept form in section B of this lesson, we already took notes on it, so you don't need that top little gap that's there. So go right down into example 1. We have the line 2x plus 3y minus 6 equals 0, and we're asked to put this in y equals mx plus b form. Okay, so we're just using algebra. We know that in y equals mx plus b, we want our y's on the left, and we want everything else on the right. So we have 2x's here. We're going to subtract 2x from both sides. And we have -6, so we're going to add 6 to both sides. Okay? Leave this term alone for now. Okay? That's how you solve things. You move stuff that's loosely attached, but the 3 is attached to y by multiplication, so we need to deal with that a little bit later in the next step. So on the left, we have 3y still, and on the right, we have -2x plus 6. Now, y equals mx plus b doesn't have 3y. It only has 1y. So I'm going to divide this side by 3. Critical error that many students make. They only divide the left side by 3. But you know, in an equation, if you do something to one side, you have to do it to the other side. So I'm going to divide both sides by 3. On the left, that leaves me with y, just like I want. On the right, it's a little bit trickier to see, but another way to say divide both sides by 3 is to say divide every term by 3. So if the group -2x plus 6, if that whole group is getting divided by 3, that means -2x is getting divided by 3 and 6 is getting divided by 3. Now we can rewrite it fairly easily. We're not going to convert this into a decimal. We love having slope in rational form because it tells us the rise over run right away. As a decimal, it would be hard to see. So this is simply -2 over 3x, and 6 divided by 3 is 2. So there you have it, and y equals mx plus b. You know you have a slope of -2/3 and y-intercept of 2. And you could easily draw that line. But we're going to go right away into example 2. Example 2 for part B says, find the slope and y-intercept given 2 points. Again, if we have 2 points, we can find the slope. So here we have point F, which is 3, -1, and we have point G, which is 5, 7. And I can find the slope of FG really easily. It's the change in y over the change in x Try to do that in your head. 7 minus -1, that's 7 plus 1, that's 8 in the top. And 5 minus 3 in the bottom is 2, gives me a slope of 4. Then to find the y-intercept, there's a couple different ways you can do it. You could use point slope form, which is what we're going to do. It's the easiest way because we have the slope and we have 2 points that it goes through. Which point am I going to use? I'll use point F. It's got smaller digits, but we're using point slope form. That's y minus y1 equals mx minus x1. Sub in what we know using point F. That's y minus -1 equals our slope, which is 4, times x minus 3. The left side becomes y plus 1. The right side becomes 4x minus 12. Make sure you distribute that 4 to both terms in the binomial. Subtract 1 from each side. Y equals 4x minus 13. Therefore, the slope is 4, and the y-int is -13. Okay, section 3 is on parallel and perpendicular lines. Section C, we took notes on those already. So on the left-hand side, you could copy your notes for parallel lines. On the right-hand side, you could copy your notes for perpendicular. I'm not going to take those notes again. We're going to go right down into example 1, where we have parallel lines. And we need to write an equation. So we need an equation of a line that is parallel to 2x plus y minus 5 equals 0. And we know it passes through point A at -1, 5. What do we know about parallel lines?
Yeah, the same slope.
They have the same slope. Can I get the slope from standard form? No. So what's my first step? Yeah, I want to convert the known line into slope y-intercept form. Slope y-int form. What does that look like? Well, I want my y positive 1y on the left. So they actually made this pretty easy for us. All you need to do is subtract 2x from both sides and add 5. So you get y equals 2x, -2x, plus 5. So the slope of this line, slope of line 1, is -2. And if they're going to be parallel, what does that tell me about the slope of the next line? It's also going to be -2. Okay? So this is a really nice way to write it down. Once you get the slope of the line, write down, because that's what you're trying to find. And then your next statement says, well, if the first line has a slope of -2 and I'm looking for parallel lines, then my next slope has to be -2 as well. And now we know the slope, and we also know a point that it goes through. So now what are we using? We need an equation of a line, so let's use point slope form. You can see how many applications this point slope form has. Y minus y1 equals m times x minus x1. We know the coordinates of a point, so we've got y minus 5. We know the slope, it equals -2 times x. I'm just going to right away write x plus 1 in this bracket. I know it's x minus -1, which is the same as x plus 1. Okay, on the right hand side, I distribute -2 to both terms. End up with -2x minus 2. And then I add 5. And actually, we want to express this in standard form again. We can do it in y equals mx plus b. We'll typically use y equals mx plus b. Just be careful when you're in your book doing practice problems. If it says to express in standard form and you do it in y equals mx plus b, your answer is going to look wrong, but it might still be right. Okay? I'm going to go to y equals mx plus b. I'm just going to add 5 to both sides. Y equals negative 2x plus 3. All right, in our next one, it's a similar problem. This time we're going to write a perpendicular line. So we want perpendicular to 3x plus y minus 6 equals 0. Again, they made it easy for you because you have a positive 1y already on the left, so you don't have to multiply it by negative 1 or by any other value to get your y by itself. But the first thing, again, we're going to be doing is converting to slope-y-intercept form. So I'm going to subtract 3x's from both sides and add 6 to both sides. That tells me that the slope of the first line is negative 3. Well, this time I'm looking for a perpendicular line. So what has to be true of the slope of the next line? It has to be the opposite reciprocal, which is positive 1 over 3. Okay, this fraction, this value, negative 3, can also be expressed as negative 3 over 1. Okay, that helps you to see, you change the sign, and you flip the fraction. All right, what other piece of information do we have? We know this thing goes through point P, which is 5, 2. So 5, 2 will satisfy the equation. We're going to use point slope form. Notice I'm not writing down the steps this time. We're just going to right away go into point slope form. I'm not even going to rewrite the equation. The general form, I know I am going to have y minus 2 on the left. On the right, I'm going to have a slope of 1/3 times x minus 5. And then simplify using algebra. 1/3 x minus 5 over 3. I'm going to add 2 to both sides. It's not going to change the x term. But now I know I'm adding a fraction to a whole number, so I need to express that whole number as a fraction over 3. Okay, 2 is the same as 6 over 3, and I'm adding it. So I've got negative 5/3, and I'm going to add 6/3. That's going to leave me with positive 1/3. So in y equals mx plus b, this is what it looks like. Okay, it's not the prettiest way to write an equation of a line because it uses fractions, but it is easy to draw because I know the y-intercept and I know the slope. The back of your book likely has this in standard form. How would I get it in standard form? Okay, add and subtract until I have all the information on the left. How do I get rid of these fractions? Multiply by 3. This one, and this one. Okay, multiply all by 3. I'm going to do that first. 3y equals x plus 1. And subtract x from both sides, subtract 1 from both sides, end up with negative x plus 3y minus 1 equals 0. These problems you will get a lot of. Okay, your practice problems have it, your assignment has it, your test has it. Lots of create a line, an equation for a line that goes through this point and is perpendicular to this other line, or is parallel to this other line. You're dealing with slope. Once you know the slope and a point, you use point slope form. Look at that, that's nice, point slope. If you know those two things, you can use it. If you don't know those two things, let's say you know 2 points, you can still find out the slope, in which case you can apply point slope form. Good. Have a wonderful day.